General relativity, step by step. I've got the four components to the Einstein field equations for the cosmological fluid here, or the four non-trivial components at least, well, they're looking pretty good basically. So what I'm going to do is use the fact that this line and this line have got the same left hand side. So I'm just going to write out that line and set it equal to that and see what happens. Okay, so let's have a go. So the first one is, let me just pinch in a little tiny bit here. So this is a dot dot over a for that one there, plus 2a dot over a all squared for that. Actually, I should tick them off as I write them. Done, done. Minus 2q dash dash upon q over a squared equals, shall I do it on the left or the right? I'll do it on the right. Equals this term here, 2, q's cancel, a dot squared over a squared, which is that term there, plus the q cancels, we've got a dot dot over a for that term there, minus q dash divided by q all squared over a squared for that term there, minus q dash dash over q over a squared, that's q dash dash upon q. Yes, because I'm divided by 2 factors of q there, plus, that's that term there, plus the 1, which is plus q squared over a squared, plus 1 over q squared a squared. Well, there's quite a lot going on here, but of course things are going to start cancelling. I'll use my red pen to cancel. That cancels that. Where's the equal sign? The equal sign's here. What else have I got? I've got a 2a squared. Oops, I meant to cancel in red. A 2a squared cancelling that 2a squared there. Okay, so I've got quite a lot of stuff left here. What I'm going to do is, in orange, I'm going to take this guy over here and add it onto there. Oh. Am I recording? Yes, I am recording. I'm going to take that and put that there. I thought it stopped. Okay, so that's a minus. Oh no, that's a q. Oh no, it's okay, it's okay. We've got a minus and there's another minus, so that goes to a plus there. So it's minus q dash dash over q over a squared equals, and that means I have accounted for that term and that term. I've only got 2 more left. Minus q dash dash over q over a squared plus 1 over q squared a squared. Well, that's quite nice. Oh, so I'm going to now assume that a is not equal to 0. I guess that means that the universe isn't all at one point, I guess, and we have this nice, hang on a minute, this isn't quite right. What have I got wrong here? That's a single dash, and that's a squared. I think I wrote down the wrong term there. There we go. So, assuming that a is not equal to 0, we have that minus q dash dash over q equals minus q dash over q squared plus 1 over q squared, or minus q dash dash q equals minus q dash squared plus 1. Or, let's just have a look at this, q dash squared minus q dash dash equals 1. This line assuming that q is not equal to 0. If it's 0, you're in a lot of trouble. Oh, well, that's quite nice. Let's just revise what I've done and then I'll talk about the equation and solve it in the next screencast. What I'm doing here, I've got the four non-zero or the non-trivial components of the Einstein field equation in this particular co-moving coordinate system, with a right-hand side corresponding to a stress energy system corresponding to a perfect cosmological fluid with pressure P 0 and temperature T. No, pressure P 0 and density rho 0. And I've chosen to use one upstairs and one downstairs index because it makes the stress energy tensor nice. And nice in this way means that I can balance these two components of the Ricci tensor against one another. Loads of stuff cancels, blah, 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 blah. And we get this wonderful equation here, which is soluble, but it's not as easy as it looks. I'm going to solve that in the next screencast. I'm going to stop there, stop.